Hi everyone, I'm Daniel. I'm a, I think you're seeing multiple links. I'm a PhD student from the Smart Lab at the University of Liverpool. And as we have been seeing today, sensing contacts around our body, particularly our fingers, is highly important, as often vision suffers from occlusions or inaccurate estimations. For instance, when attempting to grasp an object, contacts on the fingertips can guide the grasp approach, while the contacts on the inner sides of the fingers can help to decide when to close the gripper. And as we've been seeing today, two popular families of optical sensors are the tactile and the gel side. Tactile makes use of printed markers on a soft dome membrane, while gel site uses photometric analysis. And if tactile has a design close to a finger, gel site sensors typically have flat surfaces that only allow for the measurements either of the tip of the finger or the sides, depending on how you place the sensor. So in this work, we proposed the gel tip, a sensor that leverages the gel site working principle, but has the shape of a finger. As a consequence, the main novelties in this work are the usage of a transparent rigid tube as the rigid surface. And we also place the LEDs at the base of the sensor so that we can guide the light through the elastomer. And also because the surface is no longer flat, we also derive the mapping function that maps pixels in the image space into points in the surface of the sensor. Here you can see the results of our work. On the left, we have the sensor that we built in our lab, and on the right, we have a few samples. So on the top row, you can see samples of the sensor pressing against a fingertip, either on the tip or on the sides of the sensor. And on the bottom, you can see the sensor pressing against a cylindrical rigid solid. To evaluate the sensor capability of sensing these contacts around its surface, we pressed the sensor against multiple rigid objects. And we used an image-based subtraction method to find this position. And then we calculate the error between the estimated and the true position to evaluate the error of the sensor. We also illustrate the importance of all-around tactile sensing by setting the robot to grasp these blocks in an unknown position. And because the robot initially doesn't know the position, it tries to grasp random positions. But then when it collides against the block, it uses the tactile feedback to know where the block is. And therefore, it moves straight to the block position. We also use tactile feedback to know when to stop closing the gripper. So in conclusion, the proposed sensor can effectively capture the readings throughout its entire surface and can be used to facilitate grasping. However, we should point that this sensor is slightly harder to produce than the traditional gel site. And its image analysis, it's a bit more complicated as well. For future work, we plan to add markers and exploit the variable focal length lens to be able to focus different regions of the sensor. And with that, I conclude my presentation. Thank you all. You can contact me, ask questions in the chat box.
Thank you.
On my website. Thank you.